I'm going to try to talk even faster this time. All right, Vx naught. We need the first thing we have to do anytime we have a projectile launched at an angle is to break down our launch vector into its components. This is 42 meters per second times the cosine of 35. And this is, so that's what that is. And then v sub y would be 42 meters per second times the sine of 35 degrees. Don't leave it like that. Actually find what that value is. Y max, we want to know how high it goes. You've got to apply your concepts here. At the maximum height, the velocity in the y direction is 0. So I can use the third formula, Vy squared equals V yo squared plus 2 acceleration in the y direction times y max minus y naught. Okay, so now all I have to do is substitute and solve. I've got 0 at the apex. Whatever this value is, I guess I might as well figure it out. I think it was 24 meters per second squared plus 2 times negative 10 meters per second squared times y minus 0, okay, or y max minus 0. Solve that, you will find what y max is. Time to the apex. I would just use your first formula. Vy equals v yo plus a times t. Of course, the acceleration is g. We know this is 0. We can then, and we know this value, so let's substitute here, solve for time. Total amount of time. This is the amount of time it takes to get to the apex, double it, okay? Or you could use the fact that, use the second equation and use delta y equal to 0 for your displacement. Delta x, now that we have the time, just multiply it by your horizontal velocity. Velocity x direction at impact, well, it never changes. So it's going to be the exact same as we started here. The vertical velocity at impact will be equal and opposite to what we started with. So this is going to be your 42 meters per second times the sine of 35. Okay. And then the overall velocity at impact. Since we're at the same elevation, guys, it's going to have the same magnitude, but the direction is just going to be, instead of 35 above, it's going to be 35 degrees below.